We're talking about granulopoiesis. Think of it as a non-stop, high-tech assembly line that builds a key part of your immune system, and it all starts with one simple question.
So let's just jump right in with this. How does your body literally build an army inside your bones? I know it sounds like something out of a sci-fi movie, but it's a biological fact of life. We're going to break down exactly how this cellular army gets recruited, trained, and sent out into the world from its secret headquarters.
All right, first things first. Before we see the assembly line in action, let's get our bearings on the factory floor. What is this process, really? Where does it all go down? And what's the raw material we're starting with?
Okay, so at its heart, granulopoiesis is all about making a very specific type of white blood cell, the ones with granules. Now, you should think of these granules as tiny little packets of biochemical weapons. I'm talking about enzymes and proteins that these cells use to just dissolve and destroy invaders like bacteria. These are your frontline soldiers, the ones circulating in your blood, always on patrol. You know, every complex product has to start with some kind of raw material. And in our cellular factory, that material is the myeloid stem cell, or MSC for short. This isn't just any old stem cell, it's a committed one. It's kind of like a blank slate that's already been told its destiny, to create the whole family of myeloid cells. That's red blood cells, platelets, and of course the granulocytes we're focused on today. So where is this incredible factory located? It's deep inside your bone marrow. This place is the perfect headquarters. It's protected, it's rich in nutrients, and it provides a safe space for these developing cells. Plus, it has direct access to the bloodstream superhighway for when they're finally ready to be deployed.
Now, an assembly line this sophisticated and this important doesn't just run itself, no way. It needs managers, foremen on the floor giving out precise orders to control the speed and the output of the whole operation. So let's meet the molecules that are calling all the shots.
The two main bosses on this factory floor are GCSF and GMCSF. These guys are growth factors, incredibly powerful signaling proteins that act just like foremen shouting orders down the line. And get this, our understanding of them is so precise, we've even pinpointed the specific gene for GCSF right there on chromosome 17. That's incredible. So, what kind of orders are these foremen shouting? Well, it really boils down to three critical commands. First, proliferation. That's basically yelling, make more copies, we need more cells, speed up the line. Second is differentiation. Okay, you're going to become a neutrophil. Time to specialize. And third, they affect function. They even have a say in how the fully formed cells behave once they've left the factory and are out on the job. All right, we've met the managers, we've seen the factory floor. Now for the really cool part. It's time to follow a single myeloid stem cell as it travels down this amazing assembly line, transforming at every single station.
Our journey begins right here, at the very first stop, the myeloblast. Think of this as the youngest, most inexperienced recruit in the whole lineage. It's full of potential, for sure, but it's still very, very unspecialized.
So if you were to peek at a myeloblast under a microscope, this is what you'd see. It's got this huge nucleus, the cell's command center, and it takes up most of the room, packed with all the genetic blueprints it's ever going to need. But notice that last point, because it's the most important one. No granules. The cell hasn't even started packing its toolkit yet.
Next stop on the line, the promyelocyte station. Okay, so our little cell is getting a bit bigger now, and more importantly, it's starting to manufacture the tools it's going to need for its future job. The production of granules has officially begun.
And you can see the change so clearly here. The cytoplasm, that's the main body of the cell, is now getting filled up with these distinct, dark granules. This is a huge deal. It's the first visible sign that our cell is really on its way to becoming a full-fledged granulocyte. It's tooling up to be a first responder.
Welcome to what is, you could argue, the most important station on the entire assembly line, the myelocyte stage. This is the moment of decision. This is the fork in the road for our developing cell. This is the point of no return.
And you don't have to take my word for it. This quote from our source material just says it all. It's right here, at the myelocyte stage, that the cell finally gets its permanent assignment. It receives its final orders, and it differentiates. It commits to a specific career path. Is it going to be a neutrophil, an eosinophil, or a basophil? These are all different types of granular soldiers with specialized jobs. For our trip today, we're going to follow the most common one, the neutrophil.
So, having made its choice, the cell moves on to the metamyelocyte station. The focus here totally shifts. It's not about making decisions anymore, it's all about physical maturation.
The cell starts to change its shape in a really distinct way.
The key feature to watch here is the nucleus. See that? It's not a simple oval anymore. It starts to indent, to fold in on itself, forming this kind of kidney bean or U-shape. This remodeling of the nucleus is a clear, unmistakable sign that our cell is getting really close to its final form.
We are so close to the end of the line now. The very next stop is the band neutrophil, which is also known as the stab form. This cell is, well, it's basically a finished product. It's maybe 99% complete, just one tiny step away from being a fully mature, battle-ready soldier.
Just look at the shape of that nucleus now. That indentation has kept going until it's just this long, curved band, and it's often coiled up into a kind of S shape. This is the very last step before that nucleus breaks up or segments into separate lobes.
And that brings us to the very end of our assembly line. After all those stages of division and differentiation and maturation, our cell is finally complete. So let's take a look at the finished product. And here it is, the mature neutrophil. Its most defining feature, the thing that makes it stand out, is that multi-lobed nucleus. You can see 3 to 5 distinct segments all connected by these super thin threads. And that incredible structure isn't just for looks. It gives the cell amazing flexibility so it can squeeze through tissues to get to a site of infection. And of course, its cytoplasm is absolutely packed with those mauve-staining granules, just waiting to be unleashed on bacteria. It's just incredible, isn't it? This whole journey from one single stem cell to a highly specialized immune soldier is an absolute masterpiece of biological engineering. And this assembly line, it runs 24/7, pumping out billions of new cells every single day just to keep you healthy. It really makes you wonder, what other mind-blowing processes are happening inside of you right now?